students, we have completed a theory section of the chapter Thermal Expansion of Solids, and we have started discussing the numericals from this section. Okay, we have discussed some important types of numericals from the section Coefficient of Linear Expansion, and we have also started and we have nearly discussed, that means completed, some numericals of important types from the coefficient of superficial expansion. Okay, and we have started discussing the numericals from the coefficient of volume expansion. Okay, so let's start. I think we have discussed one or two numericals from the volume expansion. Now let's move to the next one. I think this will be your sum number 8. Okay, you can check it out also. Let's start. Dictating the question. A flask of volume 5.00 into 10 to the power minus 4 meter cube at 35 degrees C is made of glass having alpha equals to 4.5 into 10 to the power minus 6 per degree C. Find the contraction in volume when it is placed in ice cold water at 0 degree C. And part B is, depends, you have to find out the temperature at which its capacity is 5.003 into 10 to the power minus 4 meter cube. Okay, so let me explain you all the question. A flask is there, okay, of volume given, and it has been kept at the temperature 35 degrees C. And what is the, since the flask is made of glass, its coefficient of linear expansion is also given in the first statement. Okay, you have to find out the contraction in volume when it is placed in the ice cold water at 0 degree C. Okay, and the next part is the temperature at which its capacity is so much. Okay, so students, let's start the sum. First of all, from the question itself you can see that this is from the volume expansion. So for the volume expansion you have to calculate the gamma. So gamma of the glass is what? 3 into alpha, isn't it? The 3 into alpha means what? 3 into alpha's value is 4.5 into 10 to the power minus 6. So I can write it as 3 into 4.5 into 10 to the power minus 6, okay, per degree C. Clear? Now students, from the definition of your this gamma, contraction of 5.00 into 10 to the power minus 4 meter cube when it is cooled by the temperature, when it is cooled at 0 degree C means what? Initial temperature is given, that is your 35 degree C. Final temperature, it will become 0 degree C. Okay, so what is the change in the temperature? Change in the temperature is what? I'm just writing when it is cooled, the change in temperature is 35 minus 0 equals to what? 35 degrees C, isn't it? Now what you have been asked in the first part, find the contraction in volume and it is placed in ice cold water. That means you have to find out what? V2 minus V1, isn't it? So V2 minus V1 is what? V1 into gamma into T2 minus T1, isn't it? So write all the values. That means for V1 what we can write, 5.00 into 10 to the power minus 4 into the gamma part means this part, 3 into 4.5 into 10 to the power minus 6 into T2 minus T1 means what? This I have written, this part. Okay, this part means your T2 minus T1. So 35 meter square. Okay. Sorry, meter cube. So just calculate how much you're getting. 2.3 2.3 somewhat 62 into 10 to the power minus 7 meter cube you will get. Okay. So I'm just explaining this some students in a very short way. In the first part, in the A part, you have been asked to find out the contraction in the volume. Okay. When it is placed in ice cold water at 0 degree C. So first of all, you have to put the formula V2 minus V1, which is equal to V1 into gamma into T2 minus T1. Okay. So for this you need the V1's value. V1's value you can able to calculate from the question itself. See, the first part is only given, the value of the V1 in the first part of the question. Gamma's value you can calculate because alpha's value is given, that is just you have to multiply it by 3 because you need gamma. The relation between gamma and alpha, you just check it out, not repeating. So gamma's value you can write. Now it's coming for the value of T2 minus T1. See, in the first part and the third part of the question, you can able to check the T2 and the T1s. Okay, so do the subtraction and write all the values. You will be able to calculate the value of V2 minus V1.